Thanks for coming. We'll dive right in. My name is Eric Weiner. I'm the CTO of Near AI. We'll be talking about the Agent Interaction and Transaction Protocol, AITP, what it is and why we need it. This is a pretty uncontroversial statement. AI is going to markedly change how we interact with the world. A lot of ways, but here's one in particular. If you go back to the way that I was living my life a few years ago, or many people are living their life today, on the internet, you use websites, you use apps, those communicate with services behind the scenes. More and more these days, you're seeing the growth of AI agents that represent you to go do that thing. And I've seen a lot of talk about that today. I ask an AI agent to go book a flight. The AI agent goes and talks to a website or an app or an API, and that goes and talks to a service to get something done, especially with the growth of Model Context Protocol, MCP services. That's really helping an AI agent that is working on your behalf to go do something useful for you. But as I start to have an AI agent representing me, and as every other person and every business and every organization and every government starts having an AI agent representing them that has access to those services, then you start to have the AI agents talking to other AI agents. And a strange thing happens. It's almost like we've taken the offline world of just human interaction and scaled that up to internet scale. My AI agent, instead of using an API to book a flight, could talk to Delta's AI agent in English or whatever language they want to talk to in order to get the nuance of that interaction down to a good place. AITP is all about defining how that could happen or should happen. Again, not a huge amount of uptake for this kind of communication right now, but I think it's going to be a huge growth area. It's a protocol. There's a spec for it. It's not a crypto protocol. It's a protocol in the classic sense, in that it's a specification for how computers talk to each other. It's up at that website. It's 4 letters. I don't have a QR code or anything. And so some of the insights we had building AITP are that when AIs communicate with AIs, the communication pattern is a little bit more human-like than machine-like. And so we wanted to adopt effective human-like communication patterns. Unlike websites, APIs that default to structured data and struggle with natural language, an AI can sort of creatively combine data sets, just like a human can. My example is that this is a terrible way of finding a microwave on bestbuy.com. But it's actually a pretty good way of finding a microwave if I go to actual Best Buy and talk to a person. But humans still also use structured inputs, actually quite frequently. If I go to Best Buy and I buy that microwave, the checkout experience is kind of a structured protocol. The cashier knows to tell me a price. I know to hand over a credit card or to tap on a little doohickey, and when it says bloop, I can take it out. This is a protocol that we've all learned to do. Price tags, legal fine print and disclosures, acknowledgement of terms of service, using the turn signal on a car so that, everybody doesn't just roll down the window and say, hey, I'm turning left. These are protocols that we use in order to effectively communicate by dropping into a structured, agreed system. But it's notable, we do that only really when necessary. I'm not speaking in a structured protocol right now. So we envision AI to AI interactions as being primarily natural language. And another reason for that, something that you have to take into account, is that context is cheap. If I'm at Best Buy trying to buy that microwave, I can get about 150 words per minute out. And at some point, the person I'm talking to is bored or has other things to do or is unable to help me any further. An LLM can spit out text a lot faster, can comprehend text a lot faster, and so you can transmit a lot more context so that the two parties can make a much better nuanced decision. Now, there's a reasons I don't want to tell there's a reasons apart from my speaking pace, I don't want to tell my entire life story to a Best Buy salesperson, but I could more accurately describe the dimensions of my kitchen and my style preferences and everything so that they could make a really focused recommendation. Another weird thing for AI to AI interactions is that the protocol specificity like weirdly doesn't matter that much anymore. Now, if you're sending that $1 trillion transaction, you want to get it exactly right. But if you're saying, okay, I'm going to send you a structured JSON message in order to tell you to do this thing, and you have a spelling error, most LLMs will be like, all right, no problem, I'll just fix it for you. And it's just quite a strange interaction pattern where you're on a structured protocol, but you don't have to get it exactly right. Just like if you're turning left and your blinker is broken, like people still figure it out. So what do you need standards and structure for in a world where you're going to do primarily natural language interaction over the internet? First of all, you need some way of like actually figuring out how to communicate a language, so to speak. We have a protocol called AITP T01. That's like the transport protocol. And it's pretty simple. It's just a REST API, and it's compatible with the assistance API from OpenAI. So we're not really inventing anything here. We're codifying a way that people are already doing AI agents as an HTTP service. There's other ones out there. Google has been pushing something they call A2A. IBM has one. Honestly, whatever wins is great. I think as long as there's standards that people use, we are happy to codify and push forward on anything. That's not the magic of AITP. The magic of AITP is in the other side of it, what we call capabilities. Now, these are the protocols themselves, the structured communication you have between AI agents. There's a few things you need them for. One of them is human in the loop. If my AI agent is talking to another AI agent, and that counterparty says, "Look, like, I don't trust you that much. You got to escalate this to their human and have basically a digital signature from a human saying, yeah, I agree to this." How do you get that message across? How do you verify the signature on the way back? Once you have agents doing things in the real world, you hit a lot of situations where the current sort of regulatory environment, or even just the current practices of business, don't track very well for an AI agent working on your behalf, like legal fine print. You are not allowed to book a hotel room without physically seeing these 10 words. And if you're doing it through a website, you see the 10 words at the bottom of the screen. And if you're doing it through an API, in order to get an API key, you need to sign a legal document saying that you're going to show the end user those 10 words at the bottom of the screen. Now, if it's an AI, how do we say, hey, AI agent, like before this, you can book this hotel room, you need to attest that the user has seen this disclosure. This is making things a little simpler. Standard form filling. Okay, I'm going to buy something. I need your shipping address. I need your billing address. Like, these are things where it's just easier to do it in natural language. It's easier to do it in a structured protocol than it is in natural language. We may as well save that time and effort. Cryptographic operations. This is obviously anything you might want to sign or encrypt, but also I think that encompasses cryptocurrency or blockchain operations too. Here is a payload. Can you please sign this with your MetaMask key? Can you please sign this with your Near wallet? Now that's useful for many things, including payments. But I think for payments in particular, we need to go a little deeper. And so a lot of what AITP focuses on is the AITP-01 spec, which is a particular payments protocol that is AI native. Just to get into a little bit more concrete details, all of these are simply JSON messages sent over the chat channel. So when two AI agents talk to each other, they both identify which capabilities they support. Oh, I support AITP-020304, for instance. And if there's a match between those capabilities, they know that instead of sending natural language over the wire, they can send one of these JSON messages and know that the counterparty is able to interpret that and act appropriately. Then this one, this is the data request. So if you were signing up to come to this conference, maybe you could prompt the user or just prompt the AI agent to select the track that works best for them. And then the AI agent could do two things. One of them is if it already knows, your conference track, your dietary restrictions, it can just create this message and send it right back. Or if it wants to prompt the underlying user for that information, it's welcome to do so. So similarly, UIs can interpret these messages, display them as drop-downs, checkboxes, or what have you, or crypto transaction signatures. So getting into the payments piece a bit more, there is a particular need for an AI native payment protocol, and that's what we're building as part of AITP. It's built on near blockchain payment channels. If you've been here all day, you heard Ilya talk about why near is particularly suited as an AI agentic, as a blockchain for AI agents. In particular, one of the reasons, the things that are great here is, first of all, very fast, but also fast, cheap, scalable. But it also can be the root of interactions across the crypto world. A near smart contract can go sign an Ethereum transaction, can go sign a Solana transaction, can go basically operate a Bitcoin wallet for you because we've got chain signatures and because we have that intense framework of cross-chain, cross-asset swaps. When this isn't just a crypto transaction as you currently see it. There's a big feature set around fiat transactions that is a useful feature set for most day-to-day monetary transactions that we want to replicate in the stablecoin world here. So dispute resolution. If I'm paying with a credit card and that transaction goes wrong, I can go call up my bank and get them to adjudicate that and reverse it. We're going to allow AI dispute resolution options and human dispute resolution options. Escrow. How long will it take for that transaction to actually go hit the merchant? The longer that takes, the more security I have in that transaction. And also different types of payments. One-time payments, metered, if you're sort of billing as for usage, subscription payments, and even micropayments. And a point on that is micropayments have been, by and large, a failure for consumer use cases. Everybody dreams of a time when you could, of an idea of I should just be able to browse whatever article I want on the web and pay a couple cents just to view this and avoid the ads. None of those have really taken hold, but one of the reasons for that is behavioral. I don't want to feel nickel and dimed as I'm browsing around the internet. But if it's my AI that's browsing around the internet for me, it has different value judgments on this thing. It's not going to feel nickel and dimed. It's going to feel like it's being more efficient. Also, it's an opportunity to remake the referral and affiliate payment structure of the internet right now. I'll get into that a little bit more in a second. So all this comes down to, when an AI agent is talking to another AI agent and they get to the point that they want to transact capital and they want to move some money around, that can be to buy a product or to buy a service or just to use that other AI agent if its responses are worthwhile, like a therapist bot or something. In that case, they could continue to use fiat for that transaction, as most of us still do in our day-to-day life. But again, the criteria changes a little bit, and AI agents are more likely to logically choose to use a crypto-based payment method. It's just the logical way for AI agents to send and receive payments. To show you how that works, what we have here is swim lane with 4 spots. You've got your user, a human on the left, an interface they're using, and then my AI assistant, third from the left, and then somebody else's agent across that trust boundary on the right. Now, that other agent submits a payment request, and it gets forwarded sort of up the chain until I respond to it. It sort of goes that way. Now, in this case, my AI assistant decided to pop up that payment request in the user interface, but that's not necessarily a requirement. If my assistant has the means and the approval and the autonomy to go submit money itself, it could create the response to that payment request and submit that right away. Perhaps notifying me, perhaps not. Whether it does so is, of course, up to the developer and the user of that assistant. And then, because we've built it on Near, and because Near has this chain abstraction capability and this intent system built in, we can do some really cool stuff. Let's say that the service agent says, "Okay, I want you to pay me 5 Near to ship you a T-shirt." But maybe I, as a user, don't have any Near, and maybe don't even use Near at all. What we can do is we can take that payment request, send it onto the Near intent system. We can basically say, "Look, I need a trade. I've got this payment request for 5 Near. I want somebody to send me a payment request for the equivalent amount of Bitcoin, such that when I pay you in Bitcoin, you're going to fulfill that payment in Near." All this can happen driven from the Near blockchain, but in a way that I, as the user, only really have a Bitcoin wallet, not even a Near or Ethereum wallet. The other great thing about AITP payments is this built-in affiliate and revenue share system. Right now, if you're scrolling on Instagram and you see some video and there's somebody like wearing something cool, and you click on that video and it takes you over to the store and you buy, maybe you buy a shirt. The Instagram influencer who influenced that payment is supposed to get a bit of a kickback for that. It's a pretty well-established system in e-commerce, but it's broken in a few ways. There's a little bit of a controversy a few months ago when it came out that there's a Chrome extension called Honey. And what they advertise is that they like find you coupon codes whenever you're browsing, whenever you're shopping online. What they're actually doing in addition to that is if there's a referral link, if you clicked on a referral link and dropped a cookie in your browser, they swap it out with their own. So if you clicked on an ad and you bought something from that ad, and you have the Honey extension installed, they actually steal the kickback from the advertiser that you clicked on. Now, I've got no love lost for advertisers, but it's still basically somebody stealing from them. We can fix that with AITP affiliate and revenue share, and we can also compensate every AI agent or application along the entire path of facilitating that transaction. That can be the advertiser. It can also be basically a search engine. It can be your AI assistant or the developer of your AI assistant. It can be the developer of the assistant on the other side, the AI agent on the other side. The merchant basically allocates certain roles and percentages. So when the merchant says, "Okay, this thing is going to cost you $10 in, say, USDC," they'll say, "And I'll allocate that 1.5% of this can go to the search engine that helped you find this, or 4% of this can go to an advertiser." And as that request filters up the path, as that request goes from the merchant to the AI agent, to your AI agent, and onto you, each party can basically tag themselves into one of those roles, saying, "Oh, hey, I was the advertiser here. I'm going to sign up for this spot." And this is one of those places where being a smart system, being a AI-driven system, can make you do some really cool stuff. One of the obvious criticisms of such a system is, well, wouldn't everybody greedily sign up for every possible kickback or referral code they possibly could? Well, one way of solving that is a reputation system, star ratings, and making sure that bad actors get punished through slashes or through other means. But also, as this payment request gets passed from AI agent to AI agent to a UI, each of them can simply analyze it and say, "Hey, does this look legit to me?" If I was the advertiser and I get a payment request and somebody's already signed up for the advertiser slot, I basically go back to the AI agent that sent me the request and say, "Hey, what the heck? Like, let's figure this out, or I'm going to reject this payment. I'm not going to send it on to the user. It's not going to get fulfilled unless we resolve who, in fact, the actual, true advertiser was for this." So that's AITP. It's mostly a spec. Implementation's ongoing, but it really requires the people building AI agents and the people building AI agent hosting platforms to get on board. Go check it out at aitp.dev. We love feedback, issues, PRs. Please open them. If you go to near.ai, this platform has AITP integrated into it. So if you build an agent using the Near AI Agent SDK or using any of our other supported SDKs like Coinbase Agent Kit, LangChain, and you host it over on Near AI, it's automatically AITP compatible. That means any other AI agent can talk to it, or users can talk to it. It gets a UI, it gets hosting, everything for free. And we've constructed the Open Agents Alliance, which is a group of 27, I think, companies that are similarly trying to build an open ecosystem of AI agents that talk to other AI agents and can transact with each other over standard protocols in order to keep us away from the sort of walled garden that ChatGPT and Google Gemini and Apple's new Siri are all trying to build. All right, that's what I've got. Thanks so much for coming and listening. And if you want to talk, I'll be around.